So now it's time to look into the third type of probability sampling, that is stratified sampling. Stratified sampling is commonly used probability method that is superior to random sampling because it reduces the sampling error. So here a stratum is a subset of the population that share at least one common characteristic such as males or females. No, stratum is homogeneous. Stratum is homogeneous inside, heterogeneous to each other. So now I identify relevant stratums and their actual representation in the population. Then you do the random sampling. So random sampling is then used to select a sufficient number of subjects from each stratum. Then stratified sampling is often used when one or more of the stratums in the population have a low incidence relative to the other stratums. So if you put it in much simpler way, stratified sampling is a probability sampling technique that involves dividing the population into subgroups or strata. We call that as a strata based on a characteristic of interest and then selecting a sample from each subgroup in proportion to its size in the population. So this technique is used when the population is heterogeneous and when there are important subgroups that need to be represented in the sample. So let's take a simple example to make this explanation much easier. So let's take, so this is our population. Again, similar example, a population, city population or urban population, and this is what is our area point of interest for now. So now this is our population. These are our elements in that population. You can see on the screen clearly. So each element, let's take each element in our population now. So now once you have done some analysis on your population, if you see our population clearly, this population is heterogeneous. You have a different important subgroups that need to be represented in sample also. You see, you have kids, you have middle-aged people, you have old-age people. So you can clearly see there are inherently subgroups when it comes to a city population. So now, as per our problem statement, we need to make sure that this subpopulation or subgroups should also be representative or should be represented in our sample also. Okay, so now to do this, to to solve these kind of problems, to work on these kind of problems, you need stratified sampling. So now how do we do the stratified sampling? Stratified sampling, so once you have identified, so now I have identified my subgroups in my population. So once I have identified three subgroups. I call them as a strata. So one strata is teenager. Okay, this is one strata, and then another strata. One strata is a teenager. Their age is below 20, and another group I represent. Another group I found out was adult group, which whose age is in between 20 to 50, and then final one is seniors. Their age is in between 50 and above. Okay, so these are the three different stratums I have made. So once I have created three different stratums, if you observe them, at least one characteristic is similar. What is that characteristic? Their age. Okay, so now these three stratums with different sizes are homogeneous with respect to the age, but they are heterogeneous with respect to the some other characteristics. And if you see that they are homogeneous inside the stratum, all stratums age, the entities or elements which are inside the stratum is in between either 0 to 20 or 20 to 50 or 50 and above. So now they're inside the stratum, they are homogeneous, but in between the stratum and stratum they are heterogeneous. If you see stratum 1, which is a teenager, which is homogeneous inside that, but when it is compared with the stratum 2 adult, that's clearly heterogeneous, because this age bracket is different than this age bracket. That's why stratums are homogeneous inside and heterogeneous to each other. Okay, once you have made stratums from this, now it's time to take the random sampling. But how do you take the random sampling? So the random sampling should be now. Once that is done, so once stratification is done, then we have to select a sample from each subgroup in proportion to its size in the population. In proportion, remember that word, in proportion. So now I want a sample whose random selection with 40% of each strata. That's what. So now this is from the stratum 1, that's a teenager. These two are from teenagers stratum, and this remaining 3, 4, 5, sorry, these four are from the adult stratum, and this one is from the senior stratum. Here it is, your sample, stratified sample. Okay, I hope you got my point. I'll repeat it one more time. Let me put it in writing so that it will be much easier for you. So this is stratified sampling. So in stratified sampling, so this step 1 involves divide the population into stratas. Then step 2, once it stratas based on the characteristic, based on characteristic of interest. Then step 2, select a sample from each strata in proportion to its size in the population. That's it. Then finally, put all three together. Put all sampling units. That's your sample. Okay, so now let's take a simple example so that it would be much easier. This time we're going to do with the pandas. So example here is stratified sampling using the strata. So we want to have a we have a data set. So we'll take age as the variable or characteristic of interest. Now I have a population. That population should be sampled using stratified sampling. Okay, now let's create a data frame for that. Data frame with the age variable. So data is equal to uh, pd dot data frame, and this time I'm gonna put a dictionary. So age, teenager into 200. plus adult into 500 different, different stratums, and then again senior into 300. Okay, so now this is our data set. So I have some issue here, I don't know, senior. Okay, got it. Yeah, so data, so this is our data set. Basically we have different entities and they were made as a teenager. Total we have 200 teenagers, 500 adults, and 300 seniors. This is what three stratums. Let me put it here. So I have made three stratum from the population, three strata from the population. What are those? So size total population size is equals to capital N is equal to it's 1000. Then out of the 1000 I got the three strata. First strata is teenager. First one is teenager. And how many teenagers we have? 200. Then after that we have adults strata. In adult strata size is, let me put it here as like this: S1 strata 1 size, S2 strata 2 size, that is 500. Adults are 500. And then senior, it's S3 strata 3 size, that is equals to 300. That's it. The population has been divided into three stratas and their respective sizes. Done? Yes. So now let's create the strata from this. Anyway, strata I just shown it here. So now let's create a strata directly from here. So this is the population. So this population data consists of this information. Sorry, these are the entities in it. Now let's create stratas based on our requirement. So let's create the strata. So teenagers is equal to data and data age. And once that is done, okay, age is equal to teenagers. Okay, so this is done. And similarly adults strata. So adults strata will take all. So data, okay, data, yes, that's done. And this time again I'll go with the same age bracket, and this is adult. Just copy this and paste it here for the third stratum. Still I didn't get that issue. What's that? And final one is seniors. So these are the three: age, and then here I'll put senior. uh Somewhere it's not matching. Teenager, so teenagers is equals to data, and then the whole thing should be inside that, and data, then it's teenager. Let me bring this directly from here. Yeah, so now adult, unterminated string, literal. Okay, here is the issue. Yeah, that's done now. Let me, okay. So now let's cross check this one. Teenagers, if you want to see, teenagers stratum, and this is your teenager stratum. As I've told you, it's 200. Let me say teenagers and adult stratum and senior stratum. And similarly, let me comment these things so that it would be easier. Population size and teenagers stratum and adults. Okay, so that you can clearly see here teenagers, and then same applies to others. So now stratums has been created. Now it's time to get back to the work. So let's create the sample size for each column. Let's create the sample size for each stratum. Okay, each stratum. So it's very simple. It should be again proportionally, it should be proportional. So that's the reason I'll check round method, round function, and length of, that's what obviously it depends upon the teenagers, the respective stratum divided by length of whole data, and into 100. Okay, this is what the percentage will get here. Let me cross check the percentage, how much we'll be getting. And teenagers, these are all known one, but still just for your understanding, it's 20 percentage. So 20 percentage of data from here, and teenagers, then similarly from this one is n adults. Okay, n adults is equals to again round length of adults, length of data multiplied by 100. I need to complete this one. Yeah, again same ish. Oh, something is getting pressed. Yeah, that's done. Then similarly for n seniors is equal to round of length of seniors divided by length of data multiplied by 100. And that's it. Our sample sizes, now sample size for each stratum, that S1 and S2 and S3 in percentages, they are ready now. Now obviously based on the proportion, we need to get the based on the proportion. That is the reason we have, so 20 percentage from n teenagers, and 30 percentage from n sorry, 50 percentage from n adults, and n seniors, it's again 30 percentage. That's what the proportions. Now we have to use the respective proportions when we're doing the random sampling, final random sampling. Step 3. So combine the samples to obtain the final stratified random sample. So S stratified random sample, SRS, let me put the STS. Okay, STRS is equal to PD dot concat, and then teenager sample. Sorry, select the stratified random sample. Sorry. just I missed something. I have to. Okay, let's select the stratified random sample using the above proportions. So first one is teenager sample, that is equal to teenagers dot, let's use a sample method, and inside that n is equals to what's the value we should use now. It's n teenagers, that's it. And a random state will take one, simple, and that's it. Your teenager sample will be ready. Random teenager sample. So now adult sample. Okay, adult sample is equals to adults dot sample, and n is equals to n underscore adults, then random state is equals to 1, and this is done. Okay, too much of nonsense today. Yeah, so this is also ready, adult sample. Then finally seniors sample, that is equals to seniors dot sample. Obviously it will take n, that will give n seniors, then random state is 1. Close it. Yep, that's it. So now let's wrap this up with concatenating all the samples. Let's combine the samples to obtain the stratified final stratified random sample. Okay, sts is equals to pd dot concat, and then I'm gonna put teenager sample, and then adult sample, then senior sample, and then close this one, and access just put it 0, and then close. So that's it. It's ready. Your STS is ready. Now let's put it in a similar fashion that we have used earlier. So let me take this one. So where is that? Yeah, I'm going to use here. So study population is data, and then this one is stratified stratified random sampling is STS. And here is that magic. From study population has been converted into stratified random sampling, and 120 rows you got. From 1000 rows, it has been converted into the 120 rows, and each subgroup. So each subgroup has taken importance, as given importance here. So in this example, we first created a data frame data with an age variable that you can see in here. That contains the age group of each individual. We then create the strata by selecting the subset of individuals that belong to each subgroup. Okay, so that's how the stratified sampling works, and I hope you understood this well.